Got it. Okay, for those of you listening at home, Abby, we are looking at circles. I did want to recreate this thing when we're analyzing conics. There are 4 different types of conics we're playing with. Circles, ellipses, parabolas, and hyperbolas. The only ones we've touched, other than last week when we were talking about slicing a cone to get these shapes, is circle. So the number of analysis parts, see who remembers, don't peek. Well, peek if you have to. How many analysis parts does a circle have? Go. 2. And at the end of the chapter, there are going to be 3. Nate, how many in an ellipse? Go ahead and peek if you have to. 12. There'll be 12 different parts you'll have to identify in an ellipse when we get to analyzing an ellipse. For circles, you just have to analyze 2 things, a center and a radius. Those are the only 2 things. Eventually, I'll give you a 3rd. And then eventually, I'll give you a 13th for ellipses. So at the end of the chapter, we're going to get 1 extra thing for all of these. Parabolas have how many? Yeah, 5, correct. And at the end of the chapter, we'll have 6. And anybody remember hyperbola? The biggest of them all? 14. Which at the end of the chapter, we'll have 15. Okay? So I'll keep that up on the board for a little while. Back to this. Quick summary for those of you watching at home. Here's the formula for any circle. Memorize it. I will ask you for all the general formulas at the end of the chapter. I'll say on the chapter test, like question number 2 or something like that, list all 4 formulas. List all formulas for circles, ellipses, parabolas, hyperbolas. Some of these actually have 2 formulas. But a circle just has this. X minus h parentheses squared plus y minus k parentheses squared equals r squared. Where r happens to be the radius and h comma k is the center. Make sure it's subtract, subtract. If it isn't, you have to fix it. X plus 3 is really x minus negative 3. And the radius on this thing is 7. So 7 squared. Does that make sense? Is everybody feeling comfortable with circles so far? Think you can analyze and graph these? The question came up, do you ever have a circle that has a radius that's not a round number? Yeah. Go ahead and write that down. Quick example. X squared plus y squared equals 13. I would like somebody to put this in standard circle form. It's not quite in standard circle form yet. It's close, yeah.
Parentheses.
Okay.
X minus 0.
Good.
Squared.
Squared.
Plus parentheses y.
Oh, they're changing the dumpster. Go ahead.
Y minus 0.
Good.
Squared.
Equals.
13.
And what's the radius?
Square root of 13.
Square root of 13. Here's how I would write it. Radical 13 parentheses squared. If you want to get it into standard form for circles, there you go. That flushes out the center and it flushes out the radius. So, Josh, where's the center? It's at 0, 0. 0 comes 0. Where's the radius? It's radical 13. Correct. Now, radical 13 is a bad number. It's not evil, but bad as far as not very neat. Can somebody tell me radical 13 is between what and what? Whole numbers. Go.
3 and
It's between 3 and 4. How do you know that?
Square root of 9 is greater than square root of 16 is 4.
Yeah, radical 13 is between radical 9 and radical 16. Radical 9 is 3, radical 16 is 4, so this has got to be 3 point something. Does that make sense? And it's probably close to halfway in between. It's close to 3.5, maybe 3.6, something like that. Does that kind of make sense? But it's 3 point something. What I would do in graphing this thing, start at the center, 0, 0. I'm going to do the radii. Remember my old high school math teacher, God rest his soul, said, if you label it, it's legal. I'm going to label this as radical 13. Negative radical 13. Radical 13. Negative radical 13. Draw your circle. Does that make sense? On another circle where the center is somewhere else, you might be doing like 1 point at 2 plus radical 7, 2 minus radical 7. It might be a little more involved than these, but it's not something we haven't seen before. Would you feel okay so far? So I'm about to throw something new at you. Well, it's new and old at the same time. I need my computer for this one because I had an example typed up. Perfect. Example, go write this down. X squared plus y squared minus 6x minus 2y plus 1 equals 0. All I'm going to say is graph and analyze. And we'll do this one together. But on the test, that's all I'm going to say. Here's the formula, graph it, analyze it. Anybody have a guess as to what shape this is? What do you think? This is off the top of your head. No death penalty if you're wrong. Might be a parabola. What makes you think so? Squared. What other shape have we run into that has squares? Go. Circle. How would you tell the difference? Go.
The y squared and this one.
Both the x and the y are squared. This is going to be an important point. Write this down in your notes. If one variable is squared and one is not, that's called a parabola. That's how to tell a parabola apart from anything else. If one variable is squared and the other variable is not, it's guaranteed to be a parabola. What happens if both of them are squared? If the two variables are squared, there are actually 3 possibilities. It could be a circle, an ellipse, or a hyperbola. So how do you tell the difference? A circle, I'm not going to tell you the other two yet, the ellipse and the hyperbola, but I will tell you how to identify a circle. If the two variables are squared, if their coefficients are the same, the coefficients are equal, and the signs are equal. both plus or both minus. That's a circle. In other words, if I gave you this, x squared plus 5y squared equals 3. X squared minus 5y squared equals 3. X squared minus y squared equals 3. X squared plus y squared equals 3. One of those four is a circle. Which one? Go. Let's, oh, this label. A, B, C, or D. What do you think? D. This is a circle. What gave it away?
The coefficients are equal of the two squared variables.
Yeah, both variables are squared and the coefficients are equal. By the way, if the coefficients are equal, they will have the same sign. I just want to make sure if like one's positive one and the other's negative one, it's not a circle. Speaking of which, this one on top, they're added, they're both squared, coefficients are different. I'll give you a little hint, you're not supposed to know this yet. But there are two halves of a circle, depending on how you split it. I'll say left half, right half. If you subtract instead of add, ever look up here? It's kind of a visual thing. If you subtract instead of add, instead of joining the two pieces together, you're going to split them apart. It's going to go opposite directions. Anybody know what shape that was? It's two branches going away from each other. That's a hyperbola. Again, you're not supposed to know that yet. But anything with a square minus a square, that's going to be a hyperbola. Again, you don't know that yet. Well, you do, but you don't. What if you have both of them squared and addition, which means you're joining them together, but one number is different than another? This is the height multiplier. This is the width multiplier. If you have 1, 1, and that sounds stupid. If you have one of them as the number 1 and one of them as the number 5, watch what happens. What just happened? What is it? Joe? It's an ellipse. It's a flattened or stretched out circle. And this one, you notice both squared but minus, both squared but minus. This thing is an ellipse. This is a hyperbola. And this is a hyperbola. So if you can spot a circle from a distance, look and see if there are two variables squared, see if the coefficients are the same, and see if they're both added. What do you think? What shape is this thing? Take a wild guess. It's a circle, exactly. Why is it not a hyperbola? What causes a hyperbola? Circle is when you join two sides. How do you get a hyperbola? There's one little change. Yes, one of them is negative. If this were x squared minus y squared, hyperbola. Or if it were negative x squared plus y squared, hyperbola. Why isn't it an ellipse? Well, why isn't this thing an ellipse? An ellipse is when it squishes or gets elongated.
The coefficients are the same.
Coefficients are the same. If the coefficients are different, that means this one is 5 times as big as this. That means the width is 5 times as big as the height. So it stretches, or it stretches this way, one or the other. Make sense? Depending on which one you're multiplying. If the coefficients are different, that means that the two distances are different. That's an ellipse. This is a circle. It's not in the right form. It's nowhere near the right form. It looks like a disaster area. Someone just came and took a shotgun to our circle. Well, I need to get it in circle form. Do y'all remember last chapter before? I think it was a chapter before. Something called complete the square. It's coming back. I'm going to do what I call a double complete the square. Go ahead and write this down. Double complete the square, ironically enough, is easier than a regular complete the square. Here's how you do it. Step one. Group the x's together. Then group the y's together. And then get the answer, or get all constant numbers to the other side. That's step one. Let me show you what that looks like. Oh. What does that mean? Oh. Can somebody list off all the terms with x in order? Katie, help me out.
X squared.
X squared?
Negative 6x.
Yeah. And here's what I'd like to do. Group the x's together and leave a blank. Group the y's together, leave a blank. That's kind of like what we did with the regular complete the square. It looks like this, plus blank, and then close the parentheses. Once you see this in action, it's a lot easier to remember. Plus, can somebody group the y's together for me? Nate. What are all the y terms? Minus 2y, and then plus blank. Equals, can you get all the loose change, all the constant numbers on the other side? Okay, are there any? Are there any numbers that we haven't covered yet? The 1. How do you get it over on the other side? Exactly. Subtract 1 to the other side. And what would you get? Good. That's step 1. Ever right? Step 2. Undistribute coefficients for the degree 2 terms, if necessary. In this case, it's not necessary. If this had been like 4x squared, I'd be pulling a 4 out. If this were like 9y squared, I'd be pulling a 9 out. Not all the way in front, but just in front here. Does that kind of make sense? So if you had numbers in front of the x squared or the y squared, I'd be pulling them out in front right now. In this case, we don't have to. Step 3. Compress into, and I'm going to use my abbreviation here, compress into binomial squareds and balance the other side. See what that means. It means, can you go back in time and tell me what binomial squared it came from? Who's feeling brave? X squared minus 6x plus blank, what must they have started with? Mary Claire, what do you think? What's the 3-step pattern for a binomial squared, by the way?
Square the first, double product, square the...
Right, square the first, double the product, square the last. If this is square the first, what must it have come from?
X.
X. What's this?
Minus 3.
Yeah, how do you get minus 3?
Half of minus 6.
Right, this is double the product, so you undouble it. So what should this have been?
9.
9. Positive or negative?
Positive.
Positive, because anything squared is positive. Just be careful. See there's an extra 9 there? We got to add it to both sides. Otherwise, it's fine. Can somebody give me the binomial squared that this thing came from? Rainey, help me out. It's square the first, double product, square the last. What must the first term have been?
1.
Definitely. And then what's here? It's minus something. This is a double product. What was it before they doubled it? 1. Exactly. Ever see where that came from? If this is doubled, you undouble it to get here. What number should have been here? Square the first, double product, square the last. 1. Now there's extra weight here, which is fine, but got to add to both sides. Does that make sense? So far? Can somebody add those up for me? Chelsea, what do you get?
11.
This is
Oh,
negative.
sorry, 9.
9.
Sorry.
Good. You notice something? It's almost in circle form now. Actually, it is in circle form. Ta-da! What's the center? Let me see. Megan, take over. What's the center of this thing?
34.
Exactly. What's the radius? Yeah, it's a radical 9, which is 3, and you're done with the analysis. Once you get it in the right form, it's a lot easier. Graph it. Nick, take over. Where do you start?
Center,
Yeah, where is it?
3, 1.
3, 1, all right, got it. And always label your stuff. Go ahead.
Go up 3.
Okay, where would that be?
4, 3.
Up at 4, well, 3 got 4, yeah. Uh-huh.
And then down 3, so -2.
-2, so down 3, okay. You're gonna look stupid, but that's okay, not the first time. Go ahead,
You can go right 3.
where is that? 6, okay. Make sure you don't put it on the x-axis by mistake,
Left 3, 0.
which would be at 0. And now, flying numbers. There you go, done. Does that make sense? It's called the double complete the square, which is make a binomial squared plus a binomial squared, and send all the other junk to the other side. Make sense? Give me a quick sec, let me grab the photocopies right back.
I just looked like 1 minute ago. I know what you're gonna say, don't say it. This is vulgar and inappropriate.
Righty, this is your assignment, it is due tomorrow. And that is all the notes I have for you. So you have a little over 15 minutes. It's not that long. You have to let me know if anything is smudged. Just as a review, number 1 and number 2 should be pretty straightforward. Get it in circular form, and then graph and analyze, basically. Number 3 and number 4, they gave you the ammo. Just give me the equation. You do not need to graph it. Number 5 and number 6, all they give you is the center and a point on the circle. You give me the formula, the final formula, in circular form. And then 7 and 8 is what we just did up on the board. Put it in circular form with double complete the square, and then graph and analyze. Make sense? Okay, call me over if you get stuck, or come on over if you get stuck. Otherwise, good luck. Oh yes, and for those of you watching at home, I will email this to you. This is 6A-1, ta-da, and we'll talk to you soon. So take care, bye-bye.